I'm making right now is a Hotend. And exaggerating the heat sinks on it right now. Got a 1-inch piece of aluminum bar stock. The nipple end is turned down to a stock size. However, the outer diameter is at 1 inch, so it's 300 thousandths over what stock would be. So basically, this allows it to cool down quicker, and this will be the second extruder head for the other 3D printer I'm building. Since I have all the electronics for it and I have a frame built, really it's just a matter of putting an extruder together, and that's what this guy is right here. So basically I'll end up putting in 2 more sinks, and then at the bottom I will drill a hole that's off center to put in the resistor that heats it up. The idea is to keep the heat away from the top of the shaft. That way the plastic doesn't melt prematurely, basically clog it. Which is a problem I'm having with the crappy one I have right now. I'm free turning all this, so that's all by eye, and I'm within about 15,000, so I mean, I guess I still have the
old man's touch for running a lathe. And that's pretty close.
So, if you do this kind of thing, I mean, I'm just using WD-40 to cool it down. In the machine shop, you can use anything from kerosene to chicken fat, really, to cool it down. The idea is once you cool it down, it gives you the ability to cut faster. So I gotta make one more heat sink cut, and then I'll flip the part around. And since I trued it up to begin with, it should be a pretty quick process. So basically, that should put me pretty close. Back it off a little bit, right about there. Like I was saying, I'm just doing it by eye. I'm not really taking the time to bust a caliper out to make sure each sink is exactly the same width as the other ones, because it's not really relevant. But, you know, it's a fun little project to do, I guess, with your kids, if they're around, whatever, if you got something to do. The lathe itself is an old MCO 5 I picked up for about 175 bucks. The guy didn't know what he had. And, basically I had to redo the waves and a couple of other parts on it because it was pretty beat up. And as you can see now, it's just fine. The tool I'm using to cut with is just a high-speed steel square off. Nothing fancy. Basically I'm just feeding it until I hear the motor load up. And as long as the chips keep coming out in a stream and then break, I'm fine. It's when they come out curly cues and you can't do much with them, you got a problem. So it's a pretty quick process. I mean, it'll probably take me another hour to finish this thing all the way out. And basically, I'll drill through a hole for the filament to go through and on down the line. The cost of an extruder is about 30 or 40 bucks. When you hear it rocking like that, that means that you got to put some lube in there. It's getting ready to catch or basically blast itself off the chuck. You don't want to do that. It just causes you more problems than anything else. The cutter I have, it's got a little bit of a relief grind on the sides. That way it doesn't cut the side walls simultaneously. So that way it doesn't have to be perfectly square in the tool holder. But as you can see, I mean, it doesn't take much to do this. I'm just kind of feeding it in and away we go. The ultimate goal is 5 of these, and I think we'll get there pretty quickly. When you're doing it by hand, too, you can kind of feel when the tool is starting to jam. You'll actually feel it like ripple, if that makes sense. That's pretty close. And then you just want to knock all the crap down so you got whatever got going on. Now run in, I'll cut one more. The thing you have to watch for on this when you get in this close into the chuck is you got to make sure that your tool holder is not going to hit the chuck, which in this case, if I go right there, if you can see in there, I mean, I should just clear it. And basically what I'm checking to make sure is that this piece right here does not jam into it. So what I'll do is I'll actually back the relief off a little bit. Right about there. And I should have maybe 20-30 thousandths of clearance. Not much. But it's enough to get the part cut and get it to where I need it to be. So basically I can't go any deeper than that, otherwise I'll ram the tool holder into the chuck itself. The thing you got to watch for is, when you're doing this, is that you got to watch for all of the relief. There's a couple of ways to get around this problem. I could move the tool out or whatever, but anyways, just so you guys take interest in that. All right. So you can see I flipped it around real quick to get it going again. Nothing too special about that. So this will be the last heatsink cut I make, because the rest of it's going to have to get used for the resistor. That's got to come in a little bit. Yep, right about there. I don't normally like cutting it like this, where the cut is on the end, because it's not the stablest way to cut it, because, you know, before I had all the material there to provide that support. Now cutting like this, I mean, it doesn't really matter, because I still have about 625 left on the center. Well, whatever. So we'll run this down until we get that last sink, and then basically what will have to happen is I'll drill a through hole, and then I'll drill an offset hole side for the sink to go in. Now, there's a couple of ways I can do it. I can thread it as a male on the end, or I can thread it as a female. And basically what I'll do is I'll probably thread it as a female, because that way I can put a steel insert in to attach a nipple to. Because aluminum, it's okay if you only have to spin a part off once or twice, but when you start having to spin it off maybe daily, aluminum threads don't hold up that well. I mean, it'll be fine if I have a steel insert in there. That way, at least the heatsink will not get destroyed in the process. Basically, I'll go until the 4th and 5th match up for depth, and I know I'm at the right spot. Which is right there. Yeah. So now what I'll do is I'll buzz the outside just so it's clean, and then I'll drill an offset hole for the resistor to go through. And the idea is you don't want that hole to be anywhere near the center. This is really nothing more than a cleanup cut. fine touch off on these. You gotta go slow though, because you don't want to bend them when you're doing it. And it just cleans them up a little bit. I'll have to deburr them still, but that's really besides the point. I may be only taking off 20 thousandths too. I mean, it's not enough where it actually be putting any pressure on the heat sink or on the rib. All right, that's that. If you want to cheat on deburring them, easiest way, sandpaper. If you want a really nice finish, just get a piece of emery cloth when you're doing this, and obviously be careful what you're doing because it can catch like this, and the last thing you don't want to do is have it grab you and pull you into the lathe. Generally speaking, I will never wrap anything around it, and I use one hand and I make sure it's loose in my hand. That way if it does grab it, it can take it and I don't have any issues. Alrighty. That is that.